Hi, everybody. Thanks for joining us for a virtual trip through Saturday Science as part of the Investing Now group. My name's George, and I'm largely responsible for the undergraduate program here in chemistry. And I want to introduce you to Dr. Tamika Madison. Tamika is another faculty member in our department. And more importantly, I think it's neat to tell you guys that she is a past member of Investing Now. When Tamika was in high school, she spent time with us as part of the Investing Now Saturday Science program. So without further ado, here's Tamika to give you a little bit of fun and chemistry together. I also think I should mention before I introduce Tamika start speaking, she doesn't have a mask on, but that's because she's far away from everybody else. So we are doing this very safely, following all the COVID protocols.
Hi everybody, as George mentioned, my name is Tamika Madison. I am a local Pittsburgher, and I was an Investing Now student as a high schooler in the late 90s. I graduated in 2000 from Brashear High School, and then I got my bachelor's and PhD from the University of Pittsburgh. And I currently am a faculty member and I teach mostly freshman general chemistry classes and some other classes, and I'm also a chair of the Gen Chem class here. Okay, so a lot of the things you're going to see in this video show a lot of some of the fun aspects of chemistry. And in chemistry, we are really interested in molecules and how the properties of those molecules affect, bulk properties that we can see with our own eyes. And to sort of show you that, we're going to look at two gases here. Well, several things that can be gases. So I have two balloons, and I labeled them for my own sanity. One is a carbon dioxide balloon, and one is an oxygen balloon. And I use a clear balloons here so you can see that they're clear, colorless, odorless gases. One, oxygen we breathe in, the other we breathe out. But based on what you can see, it would be very difficult without the labeling to tell the difference between these two gases. So how can we tell the difference? So we can look at their properties. So we can look at what both of these gases do when they're, for example, subjected to really cold temperatures. And to get the really cold temperatures, I'm going to use liquid nitrogen. So nitrogen is one of the gases that is in the air. It's actually the majority of the gas, about 80% roughly, is nitrogen. So we usually experience nitrogen as a gas. But if you take nitrogen and you cool it to extremely low temperatures, it becomes a liquid like most other gases that you subject to really cold temperatures. So you can think of water, a steam, you cool it down, it becomes liquid water. So liquid nitrogen is extremely cold. It's around minus 196 degrees Celsius. So it's kept in a special container called a dewar. And the dewar is a container that has two walls, and in between the walls there's nothing. There's a vacuum there. So it helps to keep really cold liquids, help them to remain cold. I want to make sure that I'm safe, so I'm wearing a lab coat, so one layer of protection. I'm also wearing safety goggles. And I'm also going to wear these special gloves that fit this purpose to protect my hands from the cold. These on. Okay, and I'm going to pour my liquid nitrogen into this bin. And it's going to look probably to you like water, because it is a colorless liquid with the different content. Okay, so one thing you'll notice here right off the bat, that you see all this smoke coming off. And that smoke is actually water from the air that it's so close to this really cold liquid nitrogen that it actually sort of freezes. And one thing you probably can't see in the bin here is that when I initially pour, the liquid nitrogen is actually boiling because it's so much colder than the air, outside air, that it begins to boil. Okay, and eventually it stops. Now I have my very cold liquid nitrogen. Okay, and what I'm going to do is I'm going to take each of these balloons, I'm going to start with CO2, and I'm going to put them inside of liquid nitrogen just to see what's going to happen when I slow down the molecules that make up this gas and see how they sort of behave. Okay. So here's the CO2 and liquid nitrogen. You notice that the volume of the balloon is going down, and that's because all the gas molecules are slowing down, and you're actually starting to get closer and closer together as they stick. And what you can see here is that they form a nice white solid. So that is solid carbon dioxide. You might have experienced this before. This is dry ice. You know that when we cool down CO2 to very low temperatures, we turn it from a gas into a solid. So that's a special property of CO2, is that it can go directly from a gas to a solid. And I'm gonna leave this sitting here, and you'll notice as it sits there, the balloon will start to reinflate as the solid goes back to becoming a gas again, was a balloon. Okay, so now we have oxygen. And so the question is, will it do the same thing? Will it go from the gas to the solid? Will it do something different? Well, let's see. So the volume is going down again. I have here. So it's not a solid. And it's a blue liquid. That blue liquid, something that you definitely won't see every day. That, friends, is liquid oxygen. It makes this really nice pale blue color when it becomes a liquid. CO2 and oxygen, even though they're very similar at room temperature, it's hard to tell them apart. If you cool them down to really low temperatures, then you see that they behave a little differently. CO2 becomes, carbon dioxide becomes a solid when you cool it down, and oxygen becomes a liquid when you cool it down. And if you look at some models of the molecules, so it takes a really warm bed spot there and it's a little faster. Look at the molecule. So this one here, this is oxygen. And this one is carbon dioxide. So the molecules even look different. So when you cool them down, the CO2, because of the carbon in the middle, gives it the molecule property that allows it to stack up pretty easily. So this is why carbon dioxide goes right to a solid when you cool it down. Well, the oxygen doesn't really stack that easily because you just have two of the same atom. And so you don't get that stacking, so it becomes a liquid, as you would normally think happens to cool gas down to lower temperature. Okay, so you're going to see a lot of other really cool things, but just think about the different properties that you see really come from different properties of these molecules. The only thing left to do here is we got to get rid of the liquid nitrogen. I never want to put it, I don't want to put it back in the bin. That's that protocol. So since there's a lot of nitrogen in our air anyway, let me do this. Okay, hope you enjoy it. Have fun.